In this hands-on lab, we're going to explore the ELB or Elastic Load Balancer. We're going to create 2 instances running Apache Web Server, create a load balancer, configure the load balancer to send traffic to these 2 instances, and then verify the balance. Before you begin this lab, we suggest that you review the Making an AMI course, and that you also review the AWS docs on ELBs. Let's go ahead and make our first 2 machines. If you've not yet, log into the AWS Web Console, and then choose EC2. From here, choose Instances. You'll probably see only that My First Server instance. I've spun up several more this morning. You probably won't see all these. Go ahead and push Launch Instance, and push Continue, and select Amazon Linux AMI. Here, let's specify a particular availability zone. Let's use US East 1A. And on this page, we're actually going to put in some user data. Remember that a script put into user data will execute on the first boot. We're going to grab the text for this script from the file 0402 load balancer setup. In this file, we're installing the Apache Web Server, we're starting the Apache Web Server, and then we're setting a specific host name to display when we hit the top page. Let's go ahead and select all of this text and paste it into user data. We're going to leave Web01, but for the next server, we're going to change that to Web02. Let's go ahead and push Continue. Keep the default storage device. And for the name, let's type in Web-01, our first web server in our web tier. We'll use the production key pair we created before. And this time, let's create a new security group. Let's call it ELB-lab and give it the description ELB lab SG. In this group, we're going to allow HTTP, web port 80, and SSH, web port 22, and push Continue. Let's go ahead and push Launch and view the instances on the Instances page and verify that server is in fact coming up. While that server's coming up, let's launch another one. Again, let's choose Classic Wizard, Amazon Linux AMI, and this time for availability zone, let's choose US East 1B and push Continue. We'll grab our text, again for user data, paste that in here, but this time, let's change the name to Web02 so we can see that that is the second web server that we have, and push Continue. Select the default, and for the name, let's type in Web-02 and push Continue. Keep the production key pair and choose ELB Lab for our security group and launch the server. And go back to view your instances on the Instances page. While we're waiting for these instances to spin up, you may want to double check the naming conventions that I've used here. You can see that in this case, I used all uppercase for the first letter of the word, and here I used all lowercase with dashes between. I use these 2 interchangeably because they're the most popular naming options. You're going to choose one or the other for your architecture and stick with it. Personally, I prefer lowercase with dashes between. Excellent. So both of our instances are up now. Let's go ahead and click on one of them and copy the DNS that we have down here and paste it into our web browser. And there we can see that that is in fact Web01, which matches this server. And let's grab the second machine, copy its DNS into another tab, and see that that is in fact Web02, which we see. So now we have Web01 and Web02 up for our load balancing instances. Let's go back to the console, browse down to Load Balancers under Networking and Security, and push Create Load Balancer. Let's give the load balancer the name ELB-lab. And keep just the balancer on port 80. You could also, for instance, put in HTTPS or port 443, but we're just going to leave 80. Push Continue. This is where you would specify the health checks. Now the healthy threshold is currently set to 10, and it's checking every 30 seconds. If we left it at that, we'd have to wait for 5 minutes for our instances to become healthy. Let's actually drop that way down to 2 and push Continue. Here's where you choose the instances that you're going to add to your load balancer. Let's choose our Web 01 and our Web 02. And we can see that we're balancing across two AZs, which is the preferred way of doing things. Let's push continue. And here we verify our health checks. It's checking that an index.html file exists, which we know it does. As long as the health check gets back a 200 from that URL, it considers the instance healthy. And let's push create. Excellent. It's telling us our load balancer is being created. Let's click View My Load Balancers and check their status. Here you can see our load balancer is up. And let's go to Health Check and expand our detailed view. Here you can see that our health checks are set as we expected. And let's look at our instances. We see that they're out of service. And the reason being given is that instance registration is still in process. It's going to take about a minute for these instances to roll into rotation because we've set the health check for 30 seconds and healthy threshold is 2. So once we get 2 healthy pings from that HTTP index.html file, these are going to come up live. Let's keep pushing refresh here until we see them come into service. So after a few minutes, the status should change to in service for both instances. In my case, it took about 2 or 3 minutes, a bit longer than the 1 minute we expect. Let's go ahead and go back to our description and grab the DNS name of the load balancer that was created for us. Copy that, go up to our browser, and paste it in. And here we can see that I'm being routed to Web 01. One might think we could just open a second browser. Here I'm using Firefox, before I was using Chrome, and go to that ELB and see a different IP address. We're seeing Web 01 again. This is one of the quirks of the ELBs, and something that always gets people the first time they're using it. ELBs actually use your IP address as part of the routing. So even though I'm accessing from a different browser, I'm using the same IP address, so I'm routed to the same backend machine. Let's instead go back to our terminal and SSH into my first instance machine, which we're going to get from instances my first server. Let's open up our description tab, grab the DNS for this server, and SSH into it again. From here, I'm going to need to curl my ELB's address. So let's go back into load balancers, grab our ELB, and copy out its DNS name. Going back into my terminal, I'm going to type curl http:// and paste in the ELB. I have Web 02. Let's try that again. Here we see I have Web 01. So now we see it bouncing back and forth. This can be explained because this server is inside of Amazon's infrastructure. If you're coming from the outside, you're traditionally going to get stuck to a single IP address. But if you're coming in from a machine inside of Amazon's infrastructure, you can verify the load balance pretty easy. It's not always going to balance back 50-50, but it will be pretty close. So let's talk about costs. As of Q1 2013, the Amazon provides a free tier of 750 hours of ELB time for a single year. You are going to encounter costs for the 2 instances that we balanced across. But remember, you're always supposed to clean up. We'll go ahead and clean up after we're done doing the extra work. If you turn off the micros within 1 hour, Amazon will only charge you about a nickel. So over the next hour, I'd invite you to explore. Feel free to poke around. Here's some things to try. Try adding more instances behind the ELB. Try killing an instance and see what ELB does. Try changing the health check on your instance. You can change the check type and provide healthy and unhealthy thresholds. Once you're done exploring, let's go back into our infrastructure and close everything down. Let's first delete our ELB by pushing delete and confirming. And once that's deleted, let's go back into our instances. Find our Web 01 and our Web 02 and terminate these machines as well. Again, it will take a couple seconds for the instances to terminate. Could be upwards of 30 seconds to a minute. And once we're terminated, we can now go in and delete our security group. delete our ELB lab. And there we go. We're all deleted and we're all cleaned up. This has been the ELB lab, and we've accomplished all of this and probably a bit more.